Here we go with another Super Eagle label brand. Tall and black, Maximum X. Engine theory video. We're going to talk about the same little small percent gains that you can get here when you got the chance to mod in that direction. When you're building in this sense, you usually have to come up with a combination of parts just to make it work, but that gives you choice. And now how you choose your parts gives you that control over those small percent gains, intake, exhaust, stuff like that. Ignition timing, arguably a bit more. All this type of deal but can make the difference between an optimized setup and a setup that's not optimized. So what I was able to experience the first time in this build, in season 1, was that the combination of parts that were together here on this build, and I have information on that. I have the records on that. I might even do a dedicated video to that to get it out. But I was very impressed by what that combination was able to do, because the parts came together in a way that I didn't follow the general just put the biggest pipes on everything, go put 3-inch exhaust, do this, do that, a little short ram filter, whatever, blah blah blah, all this stuff. Just do that, whatever, whatever, cheapo 4-in-1 header or some shit like that. Nah, I was like, okay, what do I have? Okay, I saw what I have. What were the OEMs able to do with it, especially in different specs? Like, if you went and bought the car, let's say, I don't know, anytime between 1989 and even probably in 94, you could probably buy one of these at the dealer, like without it being used or anything. It would cost a lot of money for like a higher trim level, even in 90s, early 90s. When it's the same part you have to buy now, you got to spend that anyway. So there's really no difference in price. It's about which part you choose when you have a choice on what part you use, and that's where the tuning comes in. To keep the video short, I like to get one piece at a time. So this is specifically about the choice of. So this video is going to be about the intake side of things and what you can find there. Okay, so of course here I am with the car. I'll do a more detailed video as well on the steps and parts of doing an F23 swap into a F22 originally, 4th generation CB7 Accord. It's a lot more than anybody else tell you. I gotta probably even write it down and hit every point. It's been a bit intensive, so I can't really remember. I want to do that very right. So right now we're going to continue with this theory video, because what I will be doing next on this will be putting the suspension back together, getting the accessories right, plug everything in, hoses, all that, fluids, and start getting right. Then I have to do a mod with the fuel line, because of course the fuel entry line is shorter than it needs to be, of course, with this deal here. But I'll get that together. Going back with intake tuning as a nice way to continue doing a video and talking about this. What the deal is you want is first of all, a lot of this airflow deal has to be anti-reversionary. Air likes to back up. If it has what's known as low ramming efficiency, low energy density in the flow, it can easily reverse flow. Restrictions, etc., uneven areas that cause turbulence, whatever, if it's not designed properly, can even influence this. Or those areas can actually become anti-reversionary, such as having a header that is a little bit larger than the port, causes that reversion to not really want to occur at the port as well. This can occur in lots of different systems. So the idea is you want to get the pressure into the intake system and keep it there. the best you can in whatever way you can do it. I have a few ideas on how to do this based on science and other facts and other, hopefully it works out kind of deal. And then the exhaust, of course, you want to keep the negative pressure potential at the port, while you want to keep the positive potential pressure at the intake port. You want negative pressure potential at the exhaust port, positive pressure potential at the intake port, generally with a 4-stroke engine. There's not too much having to slam back in the charge like a 2-stroke, which is different, but we're talking about 4-stroke here. I'm going to do another splice to this video and start going harder into this idea and the basically what has been known about intake tuning and how different other ways of doing it work, such as air boxes, etc., resonant tuning, pipe length. All this is going to be very small percent gains. Of course, it's not going to make it break it, but it'll influence the feel of the motor. It'll influence the sound. And for what it's worth, since it's something that will already have to be done, it's worth it to actually do this in a way that's more accurate to what you want out of your build. This is a sketch of the idea I was drawing together. This is the plan for the intake system. Remember what I was saying. What you want to do is you want here at your exhaust ports, you want to enforce that negative pressure that's generated in between the pulses to increase the efficiency of the next cycle and use that energy, basically the overlapping of the energy, because you have a very large amount of energy released at once. That energy can be used to create an efficient situation for the next event, which bumps up the use of that same energy, which is where the gains come from, and especially with the intermittent nature of this transfer of energy. Essentially, it's very pronounced in a 4-cylinder, so there's no need to waste that. Especially when we're trying, especially in my position, this is a Malaise era engine for high MPG, low RPM, max efficiency. That's the design. That's what I'm looking for out of this build. That's why I went with a slightly larger engine, better compression ratio, that also has that low cam without going into VTEC, which is for that, I've spoken about it before, that lean burn, that stratified charge lean burn with the one intake valve opening, creating that swirl effect. So it's going to create all the velocity it needs to at the port, at the valve, essentially. What it's going to be lacking is pressure, because we don't need the velocity early on. Essentially, we don't need, because we're not getting that velocity yet. The velocity is going to be made at the port, so we need to allow it to see the highest amount of pressure it can, so that transfer is correct. Just like this needs to see the lowest amount of pressure possible at these low RPMs, which is a limitation. So trying to maximize that is the deal. An airbox also helps this at the intake area primarily, because now there can be intermittent phases of resonance in the sonic tuning that can lead to momentary high pressure, which, if all tuned right with the track lengths, occurs at the target RPMs and usages. Part throttle, off throttle, cruise, all of that type of deal, especially at speed, so you get slight ram cold air effect. As you can see, that I will go from a 2.5 inch to the 2.75 inch, which is that chrome pipe, the aluminum polished pipe that I have. I'll use the primary section of that. The primary section would actually be this 2.5 inch new section with a new intake filter, everything. I'll be able to design a box around it, but that'll come later. This pipe is inside of the coupler a bit, which creates an anti-reversionary area. So flow, this is high velocity, which also is low pressure, but it creates an area where it's very hard for it to reverse flow. And this delivery in between the pulses keeps the pressure high in this, to say this secondary plenum. So cracking the throttle, off throttle, everything, it can see high pressure. This whole system already is going to be good at turning that pressure into velocity anyway. So the energy loss is going to be low, because where the energy transitions are occurring at where it needs to happen. This is the idea of this system.